For this problem, we have a 14-year-old patient who's a 3 diopter hyperope, and with the correction on, their distance lateral foria is ortho, and their ACA is 4 to 1. Okay, so uh, first they want to know what their distance lateral foria would be without correction. So I want to remind you that when we add plus in front of someone's eyes, that makes them relax their accommodation, which makes their eyes diverge and become more exo. Okay, so if we add minus in front of someone's eyes, that stimulates their accommodation, which makes them converge, which makes them more eso. Okay, so this patient comes in wearing a +3 glasses because they're 3 diopter hyperope, and we want to check them without correction. So in this case, we're taking away their plus glasses, which is the same thing as adding minus. So if you think about it this way, we went from +3 to 0. So we're basically adding -3. Okay. And so their ACA is 4 to 1. And what that means is for every 1 diopter we put in front of their eyes will converge or diverge 4 prism diopters. So if we add 3 diopters of minus in front of them, we multiply that by the ACA. So 3 times 4 over 1 equals 12. So since we're adding minus, they're converging 12 prism diopters. So they're becoming 12 more ESO from ortho. So then obviously they become 12 ESO. Okay. The same patient would have to use which fusional vergence to compensate for their foria. So like I said before, whatever we measure compensating vergence as the opposite of the prism we use to measure the foria itself. That was a poor explanation. So what I mean by that is when we're in lab and someone has ESO, we neutralize that with base out prism. So they would compensate for it with base in prism. It's just the opposite of what we measure their foria in. So for this patient, it would be base out. Okay. Now, what would happen to their measured fusional vergences? They want to know negative fusional vergence and positive. So negative is how well the eyes can diverge, and positive is how well the eyes can converge. Okay, so here I have 2 drawings. So this top one will be with glasses. And like they said before, with glasses, this patient is ortho. All right, so let's say hypothetically this patient has 10 negative fusional vergence and 10 positive fusional vergence. 10, 10. Well, actually, technically, this would be 20 because we add the numbers together. So this patient with their glasses on, starting from ortho, they can go 10 in either direction, right? So here's without glasses. We know this time they start from 12 EP, so both of their eyes are a little bit inward. But when we do vergences, if you don't remember, we have the patient look ahead and they see a singular image. So their eyes are sort of like in an ortho position. So for that reason, both of the eyes have to diverge just to see the start, like the starting image, right? So maybe in this case, they would, I'm going to get the numbers wrong, but the numbers don't matter. It's just the concept. So they would have to already diverge uh, a certain amount of prism diopters just to see the initial starting image. Okay. And so the amount they can diverge further than that is limited. It's much smaller because they're starting from all the way in here and then they're diverging just to see the target. And then they can only diverge a little bit more. Okay. So by that, I mean their negative fusional vergence should go down. Okay. Hopefully it makes more sense when I explain positive. So I'll just get this out of the way. So like we said with the first example, this patient can go 10 in this direction and 10 in this direction. They can converge a total of 20 prism diopters starting from ortho. This patient, starting from ortho, until they get to 12 EP, they're not really using their fusional vergence. They're just relaxing the amount that they used to diverge their eyes to see ortho. So this isn't the eyes aren't converging in this portion, they're just relaxing. And then once they reach the 12 EP, which is their resting state, then they can converge an additional 10 more with each eye. So in this case, they can go a lot more inwards. And because of that, the positive fusional divergence goes up. I'm sorry, this was very confusing to explain. I hope that made sense, but if it didn't, I'll try it again.